using propeller machinery. This is the book and chapter. We already covered the second part Tuesday. So this is the front part of that one, perspective and alternative systems. And this is a society name of the United States. They are saying naval architect and marine engineering. In old days, it was separate. Still inside the ship, the job difference is clear between officers who is stay on the operating room or steering room, top row, captain, including captain. But engineers or marine engineers are staying near the engine room, and their job is clearly defined. That's why historically the society is made of naval architects, who is mainly for officers, and then marine engineers for engineers. Engine operator. But this society is not only operating ships, but it's developing, designing, and production together. Prime movers or main engine and propeller and transmission system or gearbox and auxiliary machinery, something like electricity generator, boiler, and heating, ventilation, air conditioning. This is all available inside the building too. This building is probably not in this building. Maybe or may not. But emergency generator is located. And then boiler for the heating, and ventilation, and air conditioning. So this one is for the living quarters, and here is outside. Alternative system, there is how many screws or propellers, and what is the main engine, type of main engine, and transmission, how to connect these two, main engine to propellers. This is probably transmission. And alternative combination is a mixture of engines and others, propellers. So we need to have, when you, as a designer, you need to have a design consideration. So this is a ship with two propellers and two rudders. But this one is more popular, or single propeller and single rudder. There's one Korean student here by online. Or the Seoul ship. It's different that the Seoul ship has two propeller, but one rudder. That is another combination of alternative arrangement. And as you may expect that the size of propeller should be bigger here, comparing to twin propeller. And then also this one may have a better maneuverability or control of ship. Right? So if I say one propeller is running forward, the other one is running backwards, then we can rotate, right? So that kind of control can be done with the twin propeller. Also, when the Navy ships, they need to have a high power for high speed. Sometimes they have a twin propellers. But for the commercial ships, this one is better because it's simpler, cheaper, and also efficiency of propeller is bigger, higher than smaller propeller. That's why many commercial ships take a single propeller arrangement. But sometimes when the ship needs to operate in a shallow water, they forced to use twins, smaller twins. That is the design consideration of propellers. Same as again, Advantage of single screw propeller is simple, easy of engine control because it is one, and better efficiency, propeller efficiency. Multiple screws or twin screws for the high power, high speed ship, and better operating, turning, especially in port area or when you need to touch the berth or port by yourself, right? Touch by yourself as a ship. They need a most accurate control. In that case, you need to have a side thruster, bow thruster also, and otherwise they need help from the tugboat. And tugboat need money to operate. So there is a pros and cons. And shallow draft vessel, because diameter is not big, and turbine blade size of in the power system can be bigger and bigger nowadays. See, like this one. You already see this one. Diameter 180 meter, very big, 10 megawatts. The size is increasing as time goes on. It's similar to, so high power also the efficiency is good. That's why they increase the size. Prime movers, main engines. There can be a gasoline engine, diesel engine, gas turbine, and steam turbine. In not on the ocean, you can find a gasoline engine. As my car is using gasoline engine. Right? Truck uses a diesel engine. Right? And gas turbine is for airplane. Gas turbine. Right? Steam turbine for the power plant, electric power plant. Nuclear power plant is steam turbine. The nuclear energy gives you high temperature, high pressure steam generating, and then steam is used for rotating the steam turbine. So nuclear, as you may expect, nuclear powered ship use a steam turbine. And in diesel engine, there is no carburetor. Instead, they have a fuel injection. And then, so gasoline engine has a carburetor in old days. Nowadays, it's changing. So new cars does not use carburetor engine. They are also direct fuel injection. And two-stroke and four-stroke. Stroke means how many rotation and push and back cycle of piston, and two cycle is one full cycle or four. Usually gasoline engine 4 cycle, right? Four, up down is 4. Right? Double two-stroke. Right? But usually two-stroke engine is used. You may expect a motorcycle. Small motorcycle is a two-stroke engine, small size. Smaller and lighter, but fuel efficiency is not good. So you may remember that the smell is coming from small motorcycle is higher. Smell is not good. Right? They provide more fuel because of the fuel ignition and burning is not. Gas turbine is compact, light, high power per weight, over engine. That's why they use for airplane. Airplane needs a high power, but also need a small engine and lighter engine. That's why gas turbine is used for airplane, jet plane. 2 classes of gas turbine is aircraft and electrical power plant also used sometimes, but not many times. Right? Oh, video.
30년 넘게 의사 생활을 하면서 50이 넘었을 때 어느 날 내가 뭘 좋아하는지 모르겠더라고요. 의사를 사실은 그만두고
This is the engine room. This is the engine room. This is also the engine room. I'm going to show you around the ship's engine room. As always, we need some safety gear. Most importantly, earplugs, because the engine room sounds like this. There's a few entrances. The most used one is from the engine control room. So let's start from there. A good number of computer systems and control panels are linked to the engine control room, so the engineers can work their magic from here. Through the fire door, we're into the actual engine space. Let's start off with the main course, the main engine. The whole engine is massive, 4 deck high. It can produce 80,000 horsepower, up to 25 knots in flat seas. Forget about the puny V12 Lamborghini engines. Our ship is also V12, but the piston rods alone are twice the size of a human. And you know what they say about large rods? The cylinders are even bigger. You might be wondering, where's all the crew? Well, unlike the past, or future, all cargo ships nowadays, except for passenger and military, are designed for minimum manning. We're talking about 20-something people here on a 400-meter ship. At the back is the flywheel. All that power is transferred to the propellers through the shaft. And the big block is what we call a shaft generator. At a high enough RPM, we won't even need to use the diesel generators at all to power the entire ship. Speaking of diesel generators, we've got 5 of them. There's numerous machinery systems in the engine room. As a deck officer, some of them I didn't even know existed, but I can definitely bring you to the few important ones. Remember that time when I went into the duck keel? As you can see, the machines are placed in a way with only economics and safety in mind. There's no decorations at all, no room for luxury. The systems are in their pure raw metal form for simple execution. And the engine workshop is no exception. It's big and is well equipped. With the workshop's equipment, we can cut, we can weld, we can build anything we need while we're at sea. Not to mention we already have spare parts for almost every machine on the ship. Now we've been to all parts of the engine room, except for one secret hidden passageway.
Once the heroes enter, there's no turning back.
The emergency escape is at the bottom deck, near the shaft, and it provides another means of escape other than the entrances. However, it's quite a climb. Once you have made it to the very top, you'll come up onto the upper decks of the ship. So that was a brief tour. Check out my Instagram as I travel around the world and you'll see my live updates straight from the ship. Let me know down in the comments below if you got any questions, and as always, see you next
Right. Question? Slide. Robot design submarines. Submarine prefer to use diesel engines sometimes. So in Korea, there is only diesel submarines, no nuclear submarines. Yeah. So use propel the submarines only while on the surface, because diesel engine need air. So they charge batteries, and then submarine, when it's submerged, they use battery power. Okay? That's why the problem is they cannot stay long on the submerged. Nuclear power plant, instead, they stay longer. Nuclear submarines are big, also they can travel 60,000 nautical miles before using the nuclear fuel. Right? But Earth's circumference at the equator is the longest travel length, right? It is only 25,000 miles. So it is, the nuclear submarine can travel twice the equator, right? Without fuel. And usually the nuclear power plant has, this is a land electricity power plant has a gigawatt. But in this case, there may not have a, the diesel engine we saw in the video. Can you remember the horsepower when at the video? Nobody. 80,000 horsepower. The engine, main engine of the video. So you may expect that that kind of size of engine should be used, even though the size of the ship is bigger for that case. The submarine need more power, so compact, so probably 80,000. So that may be similar case used. And this one is for gas turbine. So you may expect there's a layers of blade and high pressure and low pressure size, okay? Compressor blade and exhaust and combustion, air turbine blade, compressor and turbine. So this is combustion is here, and outside it looks like this one. It says 400 megawatts gas turbine. You can see the size by comparing with the size of human. So it can be, it's a big one. You may expect that this one is not used for airplane. This one is used for power plant. And steam turbine is bigger, even bigger. The shape is similar, but you may expect that in power plant, they have a boiler, they generate high pressure, high temperature steam, and steam uses a steam turbine like this one, steam turbine. And then steam turbine is connected with the generator. And water is used for heating and cooling, and also electricity is coming from generator. For the nuclear power plant, this portion is replaced with a nuclear reactor. The other part is same. Theoretically, same. Three categories of diesel engines: low speed diesel, medium speed diesel, high speed diesel. High speed diesel is RPM of 2,000 more, right? And this is truck. Did I ask you about your driving of of your car? Have you had a driver license yourself? Right. What is the normal driving RPM of your car? 2000. So you see this 2000. But also there is a gearbox. Too. The truck engine, high speed. Right. But this is mainly for the ship rather than truck. Truck engine maybe even smaller and higher RPM. And medium speed diesel engine for ship is around 700 RPM. This is also used for power plant and also train engine is in this category. Land train. And slow speed diesel engine, we saw that in the video. That is slow speed diesel engine, 80,000 horsepower, right? 80,000 horsepower. And RPM is in this range, around 100 or a little more. So they usually prefer to use direct current propeller. No gearbox. Why? Because that is simpler and also higher efficiency. Bigger propeller, no gearbox efficiency, loss, and then also simpler. And the number of devices small. And for the Navy ships, they usually have a 2-speed range. One is cruise speed is in happy hours, cruising around, patrolling, right? But when there is an enemy coming, then there's need to have a high speed. What they call is a top speed and cruise speed. Two different speed range. But most times they use cruise speed. Right? So that engine should be support that kind of two different power range. So many times they use a codec combination, combine the diesel engine and gas turbine. So for the cruising speed, they use only diesel engine because diesel engine is more efficient than gas turbine. But when they need high power for the enemy battle, they also use gas turbine. Gas turbine is smaller, but they produce large power, but efficiency is not good. So they can use combined one. Right? So combined diesel and gas turbine is used for Navy ships. Petrobot. This is a diesel engine. Looks like a medium size, but this one is big size because you see this human and this one single. Probably how many cylinders? Probably 10 or 12. So you can see the slow speed large digger.